So today we will talk about MySQL replication. So this talk is focused on replication crash safety, and I will talk about what I mean by replication crash safety in a few minutes. But I will also talk a lot about replication internal, so I will give you details on how replication works under the hood in the MySQL server. So my name is Jean-François Gagné. I work at MessageBird. MessageBird is a communication cloud platform based in Amsterdam. So it's a relatively new company. We're founded in 2011, and we do telecommunication service on the internet, sending text messages, voice call, WhatsApp integration, and a lot of other things related to communication. Sorry, the link doesn't show very well, so it's www.messagebird.com. So we have many customers. As a telco company, we interconnect with other telecommunication carrier, and we are about 180 employees. When I joined in July, it was 150, and a year ago it was 75. So you can see that the company is growing a lot. So we have offices all around the world, so we're global. Our engineering office is in Amsterdam, and we have many other offices to be close to our customer. And obviously we're expanding, so if you have any questions about what we do and the opportunities that we have at MessageBird, come to me after the talk and we can exchange the details and I can give you my card. So the subject for today, we will start by an overview of replication, and then we will zoom in the details. We will talk about why MySQL 5.5 is not crash safe for replication, and then we will give the 5.6 solution and all the other complex bits around this, like GTIDs, parallel replication, which I call MTS, multi-threaded slave, and other things that would impact the way replication work, like sing bin log equals something different than one, or TRX commit something different than one. And we'll touch on other subjects like semi-sync, how it works in MariaDB, and pseudo GTID. Then closing links and other stuff. There's no need to take pictures of the slide. They will be on the internet. So you can focus on what I say and look at the slide. So don't play with your phone. It's better for everybody. So how does replication work in MySQL? So first we have a master where the writes are happening, and the master records everything that is happening on the database in a journal, and this journal is called the binary logs. So we have the binary logs here. And then we have slaves that are replicas that are following the database. So this is asynchronous. There's the IO thread here that is responsible to read the binary logs from the master and save it locally in what is called the relay log. And then there's the SQL thread that read those relay log. So read this file, write it to the local database, and eventually produced binary log for the slave to be itself a master. So this is optional. So there's a parameter called log slave update that will configure the slave to write binary logs or not. So this is an overview of replication, and this diagram will become more and more complex as we add things. But this is a good first overview. So this talk is about replication crash safety, so it's quite important to know what we're talking about when we say that this is replication crash safe. So a slave would be crash safe if after a crash of the slave, and by crash I mean either a crash of the MySQL server, the process running MySQL, or a crash of the operating system, if after any of those crash, the slave is able to resume replication. So it's able to connect back to the master, the IO thread connects back to the master, and then resume replication. And obviously I want the data, because we're talking about database, I want the data in the server to be consistent with what it should have. However, there's one thing the slave could rewind a little in what it has applied as long as it's not missing the data. So after a crash, if the slave rewinds a little in its data and gets the data back from the master, I'm completely okay with that. I would consider this to be crash safe. And so MySQL 5.5 is not crash safe. When there was a crash in MySQL 5.5, this was not happening correctly. But we often talk about the slave being crash safe, but I also call something which is the master needs to be crash safe. So if a master crashes, we want the slave to be able to reconnect to the master after it has recovered. And the same thing, we don't want to lose data. We want things to be consistent. So we will talk a little about master crash safety later. So all that with keeping the data correctly. And if we talk in terms of ACID, so a lot of people like to talk about ACID, atomicity, consistency, isolation, and durability. What I mean here is that the C, consistency, and the D, the durability of ACID, are not compromised by a crash. So MySQL adds some way of storing data, which is called the storage engine, that were not transactional in the past. This is MyISAM, so we're not talking about that. We're talking about InnoDB, TokuDB, or MyRocks, which are transactional storage engine. So intermediate master, so slave that produce bin logs and have slaves themselves, so we call those intermediate master. They qualify both as a master and a slave. So they need to respect both qualifications of crash safety. And sometimes, if depending on the way you fail over a master, sometimes the master fails and it's not possible to recover, we promote a slave as a new master. So we have to remember that slaves are potential candidate master depending on the failover scenario. So sometimes, even if slaves only behave like slave concerning to replication crash safety, we have to remember that maybe they could be a master in the future. So we have to keep that in mind. And just a note, so I am not a MySQL developer. I know replication pretty well. I'm happy to share that with you, but also understand what I'm saying. Like, just don't repeat the recipe of what I'm doing, because sometimes bugs are introduced, and it has happened in the past. So bugs are introduced, behavior of MySQL are changed, and I could be wrong on something. So remember that proving that replication is not crash safe is very easy. You just need to show that it's not crash safe. Proving that it's hard, I don't think it has ever been done. Proving that crash safe, that MySQL is actually crash safe, is something that is hard. You basically have to look in the code and show that it's crash safe. It's hard. We'll get a good intuition about how it's done, but remember that this is bugs could be introduced, and we have to make sure that we have backups and things like that when we play with data. So quickly, the state of the Dolphin. So Dolphin is MySQL, the Sea Lion is MariaDB. I'll let you read that quickly. So MySQL 5.5 is not crash safe. 5.6 introduced crash safety, but it's not the default. And things got better and better until MySQL 8, where it's crash safe by default. But if you mess up with the configuration, it won't be crash safe anymore. So you really have to know the impact of what you're touching when you're configuring replication. So now we'll zoom in the details of how replication work. So to be able to store and between restart of MySQL and between crashes of MySQL, what is important is that the IO thread and the SQL thread needs to remember where they are. And those things are called master info and relay log info. So in master info, in terms of if we talk about MySQL, master info is where the IO thread store its state. And relay log info is where the SQL thread stores its state. So we'll add a diagram to that. Sorry, the diagram comes the page after. So show slave status is a command that can show where the slave is. So we have in light green master info, and this is the file in the position where the IO thread is pointing in the binary log. So binary logs are file, and the IO thread is at an offset in that file. So this is the part in light green here. And the rest here is the relay log info. So the IO thread has also a position in the master binary log. And it also has a position in the local relay logs. So relay log info is a little more complicated. There's a position in the relay log and a matching position in the master binary log. And there are some parameters that will impact how those things are saved. So now we have the same diagram as before, but only from the slave point of view. We still have the IO thread, the relay logs, the SQL thread, InnoDB, and the binary logs. But now we have the master info here and the relay log info here. And we have three parameters, which are sync master info, sync relay log, and sync relay log info. So those things will define how often MySQL, or the slave in this case, save the master info, the relay logs, and the relay log info. So the IO thread is downloading the binary logs, and it's saving the binary logs in events. So binary logs are a sequence of events, and the IO thread doesn't know anything about what's in there. For the IO thread, it is events. And so after X events, by default, it is, I think it's 10,000 in MySQL 5.5. And it's 1,000 in MySQL 5.7. So after 1,000 events, it will save its master info. And it will also save the relay log after a certain number of events. If it would write the relay logs to disk after each event, it would be very expensive because a transaction can be hundreds of events. So the IO thread saved the relay log and the master info after X events. And the SQL thread will save the relay log info after X transactions, because now we are in the ACID world, we're in the transactional world, where the SQL thread executes a sequence of events, and in this sequence of events, there's a begin and there's a commit, and after X commits, it will save the relay log info. And this is configured by those three parameters. And there's a problem in MySQL 5.5 is that the relay log info and the master info, they are files. So MySQL 5.5 will save its state here and here to files. And it's very hard to say, not to say impossible, to put data in one file and in another file at the same time. It's very hard to be atomic. And it's also very hard for the SQL thread to write something to the database, to commit something to the database, and then to write something to a file in an atomic way. Even if we write after each event and after each transaction, it's impossible to synchronize the database and a file. So this is why MySQL 5.5 is not crash safe. And don't try to make it crash safe by setting those parameters to 1 to save after each event or save after each transaction. It doesn't work. It's useless. So just before talking about how MySQL 5.6 will make all this crash safe, we will talk about two more parameters that are more related to durability. So sync binlog and the sister parameter in InnoDB, which is InnoDB flush log at transaction commit. This is a very long name, so I will do TRX commit for short. So sync binlog is a parameter on the master to configure how often the binary logs are flushed to disk. And it can be 1 after each transaction, or it can be another parameter, which means after X transaction. TRX commit is a little different. 1 means that the InnoDB logs are written to disk after each transaction. 0 means that they are only written once a second, which is not crash safe. And 2 means that after each transaction, the InnoDB logs are written to disk from a system call point of view, so we call write, but maybe Linux is buffering the write, and so at this point it hasn't reached the disk yet, it's an operating system buffer, and so 2 will say that that is flushed every second. So 2 will be crash safe for a MySQL crash, but 2 will not be crash safe for an operating system crash. And now we can talk about MySQL 5.6 and how MySQL 5.6 will improve on replication crash safety. So we have new parameters for, so just a reminder of MySQL 5.5, why it's not crash safe. It's because the relay log info are in a file. The master info is in the file, so we cannot trust the IO thread position, and we cannot trust the content of the relay log either, because they might not be in sync. And as I said, those 2 parameters, don't play with them with MySQL 5.5. They will not do anything for crash safety. So 5.6 introduced a way to synchronize the SQL thread with the database. So there's a new parameter which is called relay log info repository, which can be configured to table. And if we configure this to table, it means that the relay log info will be in InnoDB, will not be in a file anymore. So this means that when the SQL thread will commit a transaction, it will also at the same time in the database, so in an atomic way, store its data in InnoDB. So at this point, we can trust the position of the SQL thread. And when we do that, when we set relay log info repository to table, which is not the default in 5.6, we don't need to use the sync relay log info parameter. It is written every transaction. However, we haven't solved the problem with the relay log yet. So there's another parameter which is not useful for replication crash safety. I'm just mentioning it because sometimes people say it's useful. There's a master info repository, so saving the master info in a table, but this is not useful because we cannot synchronize the position of the IO thread with the content of the relay log. This is still a file, and even if this is in InnoDB, there's no way to synchronize a file and a database. So what MySQL 5.6 introduced relay log recovery, which is something complicated that will happen if you set relay log recovery to 1. This is only done on MySQL startup, and what it will do is it will restore trust in the relay log. So there are many arrows in and out of that. So the first thing it will do is it will take the trusted position that is in InnoDB, and it will now tell the IO thread, you start from there. And so this is this arrow here that is going here, and now the IO thread will start from where the SQL thread had stopped, from the last state that was in InnoDB. And then what it will do, it will take the new relay log. Every time MySQL is started, it will create a new relay log. It will tell the SQL thread, you now start from the relay log that I have. So this is basically taking everything we have in the past in the relay log, discarding that as not trusted, and starting from a trusted position. And if you want to read it, this is basically what I said here. So said otherwise, all the previous relay log are skipped, and the SQL thread will start with what at a good position. So from my point of view, this is a good first implementation. This is what 5.6 is doing. But maybe the slave was lagging. Maybe there was a lot of good relay logs here, and it's only the last part of the relay logs that we don't trust. So it will re-download them all again. It's good for a first implementation, but I would have liked something better in the next version. So MySQL 5.7 doesn't improve on relay log recovery and doesn't change the default. So MySQL 5.7 is not crash safe by default. The relay log info and relay log recovery are not enabled by default. 8.0 improves on that. In 8.0 we have safe defaults now, but we still have a very simplistic relay log recovery. When that was started, when MySQL 5.6 was introduced with replication crash safety, I opened 2 bugs that are still opened, which are side effect of relay log recovery. I still would like people to work on this and improve this. So now we know how MySQL 5.6 can be crash safe, but this is in the most simplistic state. This is in the most simplistic configuration with file and position. This is basically an extension of 5.5. But MySQL 5.6 also introduced something called global transaction ID, which complexify things, so we'll talk about them a little. So the idea behind global transaction ID is that at the moment of a transaction is commit on a master, it is tagged with an ID, and this is done at the moment the transaction is written in the binary log. So if a transaction rolls back, there's no global transaction ID that is assigned to a transaction, because on rollback, the transaction doesn't go in the binary log. And so now, the state of a slave that is based on GTIDs is partially in the binary log and in the relay log. So it will make things a little more complicated. And there's also an option for the slave to replicate using those global transaction ID, which make things easier in some regard, but harder for replication crash safety. So a slave using global transaction ID can now move from one master to the other, and it simplifies failover. This is not a talk about failover, so I will not go into details here. But the drawback here is that if a slave has sing bin log not equal to 1, so if we do not write the binary logs persistently after each transaction, and if there's a crash, the slave will lose its GTID position, because now it will lose some bin logs. So that means that if a slave is running with sing bin log equal 0, which is an optimization that some people might want to do to get a better replication throughput, replication is not crash safe with GTID. So this is the big problem with GTID, is you need to put sing bin log equal 1 to have replication crash safety. This is basically what I write here. But you still need relay log info repository to table, and you still need relay log recovery for replication to be crash safe. And this bug here, it's a bug in the documentation. The documentation is telling you that you do not need relay log recovery, but this is false. The bug has been open for 3 months. I don't understand why it's still open. I have an example where if I do not set relay log recovery to 1 with GTID, replication is not crash safe. It's not able to resume. So every time that you hear something about replication crash safety, you absolutely need relay log recovery, and you need relay log info repository to table to restore trust in the binary logs and in the position of the SQL thread. So in MySQL 5.7, there's an improvement in the defaults. Sing bin log is now equal to 1 by default. So you do not need to set it to 1 yourself to be crash safe. And in 8.0, all the defaults are good. But if you set them back to 0 here or to some other value, you will lose replication crash safety. So MySQL 5.7 introduces something. It introduces a way to run GTID without binary logs on slave, because with 5.6 you need binary logs on slave to run with GTID. So MySQL 5.7 adds a table which is called MySQL GTID executed, where instead of storing the GTID position in the binary log, it stores them in that table. But this table, if you have binary logs on slave, is not updated every transaction. It is only updated when we rotate the binary log. And I call this a missed opportunity for replication crash safety with sync bin log equals 0. So there's another bug open here, which is another bug to ask Oracle to make GTID replication crash safe with sync bin log equals 0. But this time it only applies to 5.7. It means that I want this table to be updated after each transaction, so a slave that is crashing doesn't lose its position. This is a recent bug. I might try to do a patch on this. So I've mentioned that if a slave is crashing and it's losing its binary log with sync bin log not equal to 1, there's an impact on the GTID position. But if we think a little more, it could also have an impact on the master. So we will cover that here. So if a master crashes, and by crash here I mean an operating system crash, because we will only lose the binary logs in the operating system file buffer if this is different than 0. If it's equal to 1, it will be flushed, it will be synced to disk after each transaction. So if we have an operating system crash and we lose binary log, we will lose transaction from what we were supposed to replicate. And if we're setting sync bin log to something different than 1, it means we need some extra speed on the master. And if we need some extra speed on the binary logs, we probably need some extra speed in InnoDB. So usually people set this to 0 and TRX commit to 2 to get some extra speed. But then InnoDB and the binary logs will be out of sync after an operating system crash. And so that means we cannot trust the binary log of the master. And depending on how the slave is configured, we will have different failure modes. So the first failure mode that I will talk about is when the slave is configured to replicate with file and position, so not with GTID. So we have an IO thread that is pointing in a binary log that is gone. So at this point, the slave has executed transactions that are gone from the master binary log. And this is because sync bin log here equal 0, and the master has crashed. So at this point, the master will be restarted, and it will create a new binary log file. So this is gone here. We have a new binary log file. And so at this point, the slave is pointing into something that doesn't exist, so it breaks. So we have a violation of replication crash safety. Like the master crashes, it restarted, and the slaves are not able to replicate back from it. So at this point, we have a problem. But there's an edge case where we will not see that. So here we see the slave breaking, where like we have a big warning sign that because our slaves are broken. But I made this transition a little quick. So here the arrow is pointing in the vanished binary log. But if we have a slave that is lagging and is pointing in the previous binary log, when the master crashes and it restarted, this slave will just jump to the next binary log. So this slave will not crash, and it will not see transactions from the master. So in this case, like we have the master that is crashing, the slaves that are not able to reconnect, or are able to reconnect but are not able to resume replication, and some other slaves that are able to resume replication. It's a big mess. So we obviously have data drift. The slave and the master do not have the same data. Some slaves are broken, some slaves are not broken. So we have a big mess that, as us DBA in operations, we have to fix. But the slaves that are up to date are breaking, and it makes us aware of the problem. Things are worse with GTIDs. So with GTIDs, we have transactions that are tagged with IDs. So we might have transaction 1 to 49 that are in a previous binary log. transaction 50 to 60 that are in this binary log here, but that will go away after the operating system crash. At this point, the slave might have 1 to 58, and now the master is losing 50 to 60. When the master restarts, it will create a new binary log file, but now it will number the transaction from 50 because it forgot about transaction 50 to 60. And if the slave is reconnecting quick enough, so let's say the master has 55, so 50 to 55. The slave reconnects to the master, is asking to the master, I have 1 to 58, can you give me what's next? And the master said, well, I only know up to 55. So at this point, the slave is breaking, as it was breaking before. But if the slave is reconnecting once the master has used 60, as an example, it will succeed, and it will start back replicating from 59. So there's a race condition here that makes GTID less predictable. The failure mode of GTID is less predictable. And well, I don't like things that are not predictable in production. So I'm really worried about this situation. So you need to be aware of that if you're running this kind of setup in production. I will not cover another edge case of GTIDs. I'll let you figure it out by yourself. And if you want to read more about this, I've blogged about this, and I will even write more blogs about this subject. So if you run a master with sync log equal something different than 1, you have to be very careful about what's in your binary log. And the solution here is basically to fail over. If you have a master that is failing and you need sync log equal 0 on it, it crashes, you don't trust it anymore. You fail over to a slave. And if you have a slave running with this configuration, you have to be very careful that it doesn't become a master too quickly. So you have to purge its binary log. And if you have intermediate master, well, you have to do both. So there's one other thing that I'd like to cover is multi-threaded replication. So now we're away from the master, we're back to the slave, but now we are running transactions in parallel on the slave. So we're not one transaction after the other. This is something that is introduced in MySQL 5.6. It also impacts parallel replication. And the big thing here is that transactions are committed out of order on the slave. So if I have transaction A, B, C, D, E in the binary logs, in that order, maybe on the slave I have A, C, and E that are committed. B is running and D is pending to be scheduled. So there's some case where you could have that. But then you have a very more complex position to track of. So the SQL thread cannot simply track the position with one file and an offset. And so GTID allows us to do that, and there's a very complicated table that also allows to store that in the non-GTID case. In the non-GTID case, at this point, if you crash, the slave will try to fill the gaps. This is a fix of bug 77496. It will try to fill that gap, and this will work on MySQL D crash because the relay logs are still there, but it will fail in the case of an operating system crash because the relay log are gone at this point. So this means that file and position and operating system crash will not play well together. And there's a workaround. The workaround is to set sync relay log equal to 1 to never lose relay log, but this is a performance killer. So the good solution for that would be to have a better relay log recovery. With GTIDs, things are better. So we still have transaction A, B, C, D, E. So now they're numbered. So on the slave, they're transaction 10, 11, 12, 13, and 14. So if we crash at this point, the state of our slave is 1 to 10 are executed, 12 and 14 are executed. So at this point, the master should connect to the slave should connect to the master and get 11, 13, 15, and so on. But this is the theory. In practice, it doesn't work, and this is a very recent bug that I opened 2 weeks ago. So this is a regression of this bug because at this point, relay log recovery on the slave is trying to fill the gaps and the relay log are gone. So there's a very easy fix by doing stop slave, reset slave, start slave. It will fix this situation because at this point, the slave forgets about the gap and goes back full GTID negotiation. And it will, this is a workaround that works well, but Oracle should fix this bug. I will skip semi-sync because I'm a little short of time. MariaDB, so MariaDB is a different implementation from MySQL. So in short, MariaDB is not crash safe with MariaDB 5.5, and it will be crash safe with GTIDs from 10.0. But what I would like to talk to you about is an interesting feature in MariaDB 10.3, which makes MariaDB a good candidate to be a slave with many storage engine, because we have a table here that is stored in one storage engine, let's say InnoDB, and the SQL thread is able to synchronize its position in InnoDB and in this table. If we also add MyRocks, this is the next talk, Yoshinori will talk about MyRocks. So if we're running 2 storage engines, we only have the table in 1 storage engine, and that means that we have cross storage engine transaction. MariaDB makes things better by having 2 tables, and when it does a transaction in InnoDB, it stores its position in InnoDB. When it does a transaction in MyRocks, it stores its position in MyRocks. And there's some interesting result in Christian Nielsen's blog. Pseudo GTID, very quickly, it's an interesting way to get GTID feature without, so GTID functionalities without the GTID implementation. So it works with MySQL 5.5. And it's a way to make replication crash safe if you have log slave update on your slaves and sync bin log equal 1. So if you're still running MySQL 5.5 and you want replication crash safety, you can use pseudo GTID. And there's some documentation about this that you can read. So in conclusion, it's a very complicated subject that evolves a lot. There's bugs that are introduced and that are fixed. And so you need to make sure that you know everything about this before touching it. And the complete diagram is like that. So you can see that this is a lot of things to think about. In short, there's 3 parameters that will never impact replication crash safety. It is master info repository, sync master info, and sync relay log info. So those parameters are not useful to get replication crash safety. There are 2 parameters that are always needed. It is relay log info repository in a table, and it's relay log recovery. And then the rest, it's a combination of this parameter in this case, this other parameter in the other case. So with GTID, what is important is to have sync bin log equal 1. With multi-threaded slave, it's important to not have operating system crash right now, because with an operating system crash, you will lose your relay log. And be mindful about your binary logs if you do sync bin log equal something different than 1. There's some evolution in MySQL 5.7 and 8.0. Things are getting better, but some things also are not improving. Multi-threaded slave has many traps, and relay log recovery is still simplistic. I hope it will get better in the next MySQL version. In the slides, I have many links if you want to know more about this subject. So links about blog posts, about bugs, and about more blog posts. So that's it for me. Reminder about MessageBird, who is my employer, and it's very happy to have me speak with you today. So if you want to know more, you can go to the website, and I have to thank them because without them I wouldn't be here. And now I have times for questions. Yeah, the microphone is coming.
Thanks for a nice presentation. I have a question about master and slave replication. Imagine we have MySQL version 5.6. We have global transaction IDs enabled.
Yes.
And for example, we are doing migration to another rack or whatever, and we have like one master, one slave, and we want to promote slave to master, and former master just plug in and resume from new master.
Yes.
So if we, usual solution is to simply, transition, promote new master and then kind of dump, or do, use, backup to do, binary copy, basically, and resume this way. But what if we have like, terabyte or something,
yes,
size database? And
it's become very painful to do a restore.
To do, but it's not so straightforward, even with global
yes.
transaction IDs to do that. So what are your suggestions?
If I just summarize your problem, you have one master, one slave, and you want to fail over to the slave, and you want the old master to be a new slave.
Yes.
So your approach here is basically to drop the master, to have the slave as the new master, and then to create a new slave. This is the approach that you're describing, and it's actually very painful, as you said, because you need to restore a backup, and it takes time. So there's a way to actually invert the flow of replication, but what this needs is you need to stop transactions on the master, let the slave catch up, and then flip them back. So invert the position of master and slave. This is possible with or without GTIDs, and it's a little complicated to explain now, but if you want, we can talk about this after the talk. But it's possible to just invert the position, but it needs a small moment where we don't do any transactions on a master. Yeah, so I don't exactly know the situation where you have errors. I would need to see it to exactly understand what it is, but I suggest we talk about this after the talk. Any other questions about MySQL, about replication?
In 5.7, I think they've added something like relay log simple recovery or GTID set
yes.
simple recovery stuff, and what do you think about it and its default value? Is it safe?
Yes. So there's a parameter in MySQL 5.7 to get a quicker binary log recovery, and this is because after a crash, normally on a master, we're not talking about a slave, we're talking about a master. After a crash, because the GTID state is in the master binary log, it needs to reread all the binary log to recover the GTID state, because the GTID state is in RAM while MySQL is running. It's writing binary logs and then it crashes, so it loses its RAM, and then it needs to rescan all the binary logs to recover its state. And the parameter you're talking about, if my memory is correct, is just to rescan the last binary log. It should be safe. There's one edge case to it if I remember correctly, but so I remember there's an edge case, but I do not remember which one, so we would have to discuss it. But I'm pretty sure, like, my intuition there and what I remember, it's the default is safe.
Okay, we just found that it's either our automation bug, because we do clones through extra backup and it's considered like a recovery, or maybe MySQL with MTS slave. It may not, that optimization may be a bit broken. So if your transactions are not in order and you have like multiple levels of replication.
Well, this is what I was talking about. If you have many levels of replication and you're not syncing your binary log, you might have some edge case. But this is master replication crash safety. So if you have an intermediate master that is failing, make sure you do not have slaves reconnecting to it before you purge the binary log. But I'm interested into talking with you a little more after the talk.
Okay.
I think we have a little time for one more question.
Yeah, I can. If there is no other question,
well, maybe two.
This is related to replication. So what is your current solution for automatic failover? Like, what is the trendy solution now?
Yes. So this talk was not about failover. So this talk was more about what happened after a crash. So when a master fails, sometimes we want to promote a slave as a new master. So how to do that? So Orchestrator is a good tool for doing that, for detecting failure and to automate the failover. It doesn't solve everything. Failing over is something that is very complicated, and Orchestrator just managed the MySQL part of it. The other part of it is to tell the application where the new master is, and there's no easy way of doing this, and there's many different ways with advantages and drawback. So Orchestrator with lossless semi-sync in 5.7 would be a good part of the solution, but there's still other part of the solution that are dependent of your application, and that I cannot give an opinion on. And failing over is a complete talk. So it's even a full tutorial to do it right.
Okay, thank you for your presentation. He will have some presents for you.
Oh, thank you very much.
So
thank you.
Thank you again. If you have some more questions, you can ask in the discussion zone. Thank you.